For decades, scientists have tried to understand the rate at the asteroid hit the Earth by carefully studying the impact craters on continents and by using radiometric dating of the rocks around them to determine the ages of the largest and thus most intact ones. The problem is that many experts assumed that early Earth craters have been worn away by the wind, storms, and other geological processes. This idea explained why Earth has fewer older craters than expected compared to the other bodies in the solar system, but it made it difficult to find an accurate impact rate and to determine whether it had changed over time. So in this video, we're going to tell you that this discovery reveals ancient asteroid bombardments on the Moon and Earth. The video is gonna be amazing, so make sure you stick till the end. Before starting the video, be sure to smash the like button, subscribe to never miss out on any of our videos.
A rocket crash on the Moon has left scientists baffled. It was first reported in the month of March.
History-making moment to avoid Armageddon.
NASA carried out a first of its kind asteroid-altering mission last month.
American Space Agency NASA says it can now lay claim to the title of Defender of the Planet.
Lunar soil contains spherical droplets of the solidified melt, the glass, with sizes ranging from a few millimeters to less than a millimeter. These droplets are formed during high-speed impacts that melt the target rock. The landing site is in the middle of a vast basaltic plateau nearly 400 kilometers across. The plateau is only 2 billion years old, which is young relative to the age of the lunar crust overall. This means the history of the site is shorter and simpler to unravel. This made it easier to identify droplets originating from nearby impacts as well as interpret chemical and chronological data via satellite images of the surrounding lunar surface. On the Moon, where impact craters don't go away, several hundred million are recognizable. It's not difficult to imagine Earth experienced a similar staggering barrage of the projectiles early in its life. As the solar system evolved over the last 4.5 billion years, the number of asteroids declined exponentially over time as space rocks were swept up by Earth and the other planets. The destructive power of the meteorite impact has been seen throughout the human history. A recently notable event from the 2013, the spectacular Chelyabinsk meteor that injured hundreds of people, was a relatively minor occurrence compared to historical impacts. Impacts of various scales have happened throughout the Earth's long geological history. Only about 200 impact craters have been found around the world because erosion and geological activity are constantly modifying our planet's surface and erasing evidence of the past impacts. China's Change 5 mission sampled more than a kilogram of the moon rock and soil and brought it back to Earth. The sample contains countless tiny beads of glass created when asteroids hit the moon and splashed out droplets of the molten rock around the impact site. Researchers have shaken up a once accepted timeline for the cataclysmic events in the early solar system. About 4.5 giga-annum or billion years ago, a large disk of dust and ice collapsed around our newly formed star, planets, and smaller celestial bodies were formed. The Late Heavy Bombardment, LHB, or Lunar Cataclysm, is a hypothesized event thought to have occurred approximately 4.1 to 3.8 billion years ago, at a time corresponding to the Neo-Hadean and Eoarchean eras on Earth. According to the hypothesis, during this interval, a disproportionately large number of asteroids collided with the early terrestrial planets in the inner solar system, including Mercury, Venus, Earth, and Mars. These came from both post-accretion and planetary instability-driven populations of impactors. Although generally accepted, it remains difficult to prove. It was once thought that this period had a relatively sudden onset, but a research team at the Hiroshima University and the University of Tokyo in Japan have found evidence that this bombardment period may have started much earlier and decreased in intensity over time. The team published their findings on August 26 in Earth and Planetary Science Letters. According to Apollo's lunar rock studies from the 1970s, the Earth, Moon, and the entire inner solar system are thought to have suffered from numerous meteoritical impacts at around 3.9 GA. This event is regarded as a key process during the early evolution of our planet, said Mizuho Koike. However, the validity of the LHB idea is being questioned recently. To settle this debate, a solid database of the impact's ages is required. An international team of the scientists is challenging our understanding of a part of the Earth's history by looking at the Moon, the most complete and accessible chronicle of the asteroid collisions that carved our solar system. In a study published today in Science, the team shows the number of the asteroid impacts on the Moon and Earth increased by 2 to 3 times starting around 290 million years ago. Our research provides evidence for a dramatic change in the rate of the asteroid impacts on both Earth and the Moon that occurred around the end of the Paleozoic era, said lead author Sarah Mazarui, who recently earned her PhD in the Department of Earth Sciences. The implication is that since that time we have been in a period of the relatively high rate of the asteroid impacts that is 2.6 times higher than it was prior to 290 million years ago. It had been previously assumed that most of the Earth's older craters produced by the asteroid impacts have been erased by erosion and other geological processes. The relative rarity of the large craters on Earth older than 290 million years and younger than 650 million years is not because we lost the craters, but because the impact rate during that time was lower than it is now, said Rebecca Gant. We expect this to be of interest to anyone interested in the impact history of both Earth and the Moon, and the role that it might have played in the history of life on Earth. A way to sidestep this problem is to examine the Moon, which is hit by asteroids in the same proportions over time as Earth. But there is no way to determine the ages of the lunar craters until NASA's Lunar Reconnaissance Orbiter started circling the Moon a decade ago and studying its surface. During the lunar night, rocks radiate much more heat than fine-grained soil called regolith. This allows scientists to distinguish rocks from fine particles in thermal images. Gant had previously used this information to calculate the rate at which large rocks around the Moon's young craters ejected onto the surface during asteroid impact break down into the soil as a result of a constant rain of the tiny meteorites over tens of millions of years. By applying this idea, the team was able to calculate ages for previously undated lunar craters. When compared to a similar timeline of the Earth's craters, they found the two bodies had recorded the same history of asteroid bombardment. It's become clear that the reasons why Earth has fewer older craters on its most stable regions is that the impact rate was lower up until about 290 million years ago, said William Botka, an asteroid expert at the Southwest Research Institute in Boulder, Colorado, and another of the paper's co-authors. The answer to Earth's impact rate was staring everyone right in the face. The reason for the jump in the impact rate is unknown, though the researchers speculated it might be related to large collisions taking place more than 300 million years ago in the main asteroid belt between the orbits of the Mars and the Jupiter. Such events can create debris that can reach the inner solar system. The Canadian Shield hosts some of the best preserved and best studied of this terrain, and also some of the best studied large impact craters, said Mazarui. Gernon showed that kimberlite pipes formed about 650 million years ago had not experienced much erosion, indicating that the large impact craters younger than this on the stable terrains must also be intact. This is how we know those craters represent a near-complete record, Gant said. While the researchers weren't the first to propose that the rate of the asteroid strikes to the Earth has fluctuated over the past billion years, They are the first to show it statistically and quantify the rate. The findings may also have implications for the history of life on Earth, which is punctuated by extinction events and rapid evolution of new species, said Gant. Though the forces driving these events are complicated and may include other geologic causes, such as large volcanic eruptions, combined with biological factors, asteroid impacts have surely played a role in this ongoing saga. Let us know your opinion in the comment section below. This was all for today. Hope you liked the video. Do not forget to subscribe to our YouTube channel. Stay safe, and we will be back soon with another video.